Mr. Gordon here with today's lesson on collecting like terms. Going to do something slightly different today and split the video that I do into separate bits for each of the different tasks that you're doing. So this is just a quick introduction, and then there'll be a separate video for each of the tasks within here. So collecting like terms, what have we got in front of us here? We've got various variables like x squared, x, y, and some constants as well, these little ones here. So these are algebra tiles. You've probably used them before. I'm just going to collect like terms. I'm going to collect ones that are the same as each other. So I'm going to grab all those ones and put them over here. Okay, so let's get those together. And then let's get these x's together. It doesn't matter which way around they are. They're the same size as each other. They have the same area. And we've got all those x's together. And I'm going to get the x squareds together as well. And that's a different length to the x, so that's a different one, isn't it? So what have I got here? I've got 4. I've got 1, 2, 3, 4, 5, 6x. 6 times x, which is just 6x. I've got 1, 2, 3x squared. So that's 3x squared. And I've got a y up here as well. Okay, so if I put them all together, I've got 3x squared, I've got 6x, I've got 4, and I've got y. So the crucial part is we can't simplify this anymore because these are different things. So this x squared, it's a different thing to this x. It has the same width as the x, and it has the same height as the x, but it is like the multiplication of the x, isn't it? So imagine if that x there was multiplied by x, that x there, it would give us the x squared. They're different things. And again, the y, it's a different thing to the others, okay? So when we're simplifying, when we're collecting terms, we treat each of these things as different if they have different letters or if they have a different power. So here we've got an x squared, which is different from an x, which is different from an x cubed, which is different from a y because it's a different letter. Then we can also have, we can imagine other shapes being here as well. I'm just going to move some of these out of the way. So we could, for example, imagine, well, what do we get if we multiply an x by a y? Well, we would get an xy, something that is the same width as the x and the same height as the y. If we just rotate that y around, we should notice that's the same height as that one now, but it's the same width as the x. So that is an xy block. But again, I can't add that to the other ones. I can't simplify. I can't say that is a y. It is an xy. It's a different kind of a thing. And again, if I look at the y, I could make a y squared block by getting that y and making it the same width and the same height as that y block. So we can't add any of these things together if any of the letters are different. So as long as all of the letters are the same, we can add them together. So here we've got 5 x's. Now we might want to do 5 x's. We might have 3x add 2x. So if we wanted to visualize what is 3x plus 2x, well, the 3x is just 3 of these. So we've just got 3 of these for the 3x, and for the 2x, that's just 2 of these. So there's 2 of them for the 2x. So we're just adding together those 3x and those 2x, and we should be able to see that the answer is going to be 5x. We're just adding those together, so that's going to be 5x. So the crucial point here is if any of the letters are different, or if any of the powers are different, then they're different kinds of things, and you can't simplify them further. You can't add them together further.